when you divide by 0. And what will always happen in these limits is the number that you plug in may cause you to divide by 0, but it may also cause you to have 0 on the top of your function. And when you have 0 divided by 0, which isn't possible, but interesting things happen in mathematics when that happens. Sometimes 0 divided by 0 will result in getting really close to a huge number. Sometimes 0 divided by 0 will get really close to 0. And so there's weird things that happen when you divide 0 by 0, or at least when you get close to doing that, because you're not actually allowed to divide by 0. If I said that on YouTube, I might get fired. Anyways, here we go. We've talked about something being discontinuous if you have to lift your pencil to draw the rest of the graph. And we saw an example of an asymptote before, or a hole in the function, which we just drew. In order to get past that point, you'd have to lift up your pencil and draw it. And no, this is cheating. If you go all the way around. See, I did it without lifting it. No, that doesn't count. So that would be an idea of something being discontinuous. So what we have is sometimes, even though we have a point that's not allowed, can't plug in x equals 3, the limit still exists. And the idea of a limit is if you approached a number from the left side, and if you approached the number from the right side, and you plugged it into your calculator, and it came out to the same number, closer and closer to the same number, then we say that that limit exists. So what I'm going to do with this example here is I'm going to go to my calculator. I'm going to write it out, bracket. It was x plus 3. So I'm going to go x plus 3, bracket, bracket again, x minus 3. And what was on the bottom? Was it an x minus 3 on the bottom as well? X minus 3 on the bottom. So this is exactly as the thing that we have right now. I have some value stored in for x. When I push enter, it's going to give me a number. I don't know what value. According to my calculator, x is 10 right now. Okay? We want to find the limit as x gets close to 3. Okay? If I set x as 3, so if I say 3 and I store that as x, and I go back up to this and push enter again, I'm going to get a problem. Even my calculator knows that that's bad. Calculation by 0, calculation fails. Okay, we're going to quit. So I can't plug in 3, but if I did 2.9999, that's close to 3, and I store that as x. And then I go back up to here and type that in again. It's really, really close to 6. And if I tried a number bigger than 3, so I go 3.00000000001 and store that as x. Oh, it thinks it's, let's see. Oh, it thinks it's 3. But let's see if I can plug in that one or if it rounded it for me. Oh, it says it's really close to 6. So it seems like if we approach 3 from the left side, and that's what the 2.99 is. Can you see that if 3 was on a number line and I approached it from the left, I'd go 1, 2, and then 2.5, and then 2.9, and 2.999 is approaching it from the left side. And I approach it from the right side, I get really close to 6 either way. That's the idea that this limit exists. Mathematically, it's actually a quite easy process for this question. You can see that the x minus 3's cancel out. And once they cancel out, we would write, and we'd have to rewrite limit as x goes to 3. All we're left with is x plus 3. Now there isn't a problem plugging in 3. And so now if I do plug in 3 for x, I just get 3 plus 3, which is equal to 6. So if you can do algebra so that your problem goes away and you can plug in the number, then you're going to be able to solve these limits. And you won't have to go to your calculator and try numbers really close on the left side and really close on the right, because when you tried 3 originally, it gave an error. I've wanted to design a calculator where if you divide by 0, when you push enter, it actually gives you a little electrical shock. Sort of to, you did something not allowed. It wouldn't need to go to that screen and say error divided by 0. You would just know that you did something wrong. But they haven't been invented yet. My son did bring home a pen the other day where the pen doesn't come out, but there's a bunch of buttons on it. And one button turns on a laser, and you're like, oh, it's not that button. The other button is an electrical shock. And he got me really, he laughed for a very long time. It was the best $8 he says he's ever bought, because he's just totally electrical. Gave his dad electrical shock. So. All right, so for this example, we got -2, and if you try to plug in -2 right away, on the bottom you're going to find out that you get 4 minus 12 is -8, plus 8 is 0. So that's not a good thing. So we need to come up with some way so that we can make this factor so that things cancel out, so that we are able to plug in -2. So one of the key strategies that we did in the other day was practicing factoring, and this is the reason. Because right now, well, the bottom at least, that's something we've factored for a long time. We've got our +2 and our +4. And the top, you have to recognize as a difference, or sorry, a sum of cubes. So this is another thing that we can factor, because this is x cubed plus 2 cubed. So one of the factors will be x plus 2. This one will be x squared. This one will have to be 4. And in order for them to cancel out, you'll need a -2x in the middle. Again, you can memorize that formula that we wrote the other day. Or, same strategy I used the other day. Once I figured out that I had to have an x squared to begin with, because that would give me an x cubed. I needed a +4 at the end, because that would give me +8. I said, what will I also get? Well, if I put the x and the 4 together, I'll get 4x. And I need that to go away. So 2 times what would make a -4x to make that go away. And that's how I knew there had to be a -2x there. That's how I figure it out. But you can have the formula and memorize it as well. But figuring things out usually lasts longer in your memory than just memorizing formulas. So at this point, we now notice that the x plus 2's can cancel out. And once those x plus 2 cancel out, the -2 on the bottom is no longer an issue. If I want to rewrite it simplified, I'll still need to write the x. Right? If I'm just writing out the simplified form, I still need to write limit as x goes to -2 in front. But then as soon as I decide that I'm going to plug in that value to evaluate the limit, then I no longer need to write that limit in front, because I have evaluated it. So on the top, we're going to get 4 plus 4 is 8 plus 4 is 12 over 2 is 6. Today's examples have been brought to you by the number 6.